Lesson 4-8, Example 2. Our objective is learning to add and subtract fractions with like denominators. So here we have a problem of 1 whole subtracting 3/5. So again, we could use a picture model for this. So here's my 1 whole, and my 3/5, here's another whole. If I break this up into 5 pieces, I can show my 3/5 right here. There's 2, there's 3/5. And this whole, this is this whole thing over here. I can break this up, this whole, also into fifths by just doing this. So now I have this whole thing broken up into fifths, which 1, 2, 3, 4, 5 of those fifths. And I have my 3/5 here, so I'm subtracting 3/5. Well, I can look at this picture model and say, okay, this is going, this is going, and this is going, and what I have left over are these 2/5 right here. So I can show that right here with another picture model, that I end up with 2/5 left over. But I notice that I have 5/5 minus 3/5. 5 minus 3 is 2. And I'm talking about fifths, and that's what they are. So the fifths goes on the bottom. So 5/5 minus 3/5 is 2/5. So whenever we see a whole number, we can take that whole number and turn it into a like fraction. So if this were sixths, I could change this into 6/6. If this were sevenths, I could change this into 7/7, whatever I need to do. Another example might be if I had, let's say, 2 and 3/4, and I'm subtracting, actually, 2 minus 3/4. Let's do that. 2 minus 3/4. Well, I can take one of those wholes and turn that whole into fourths. So 1 4/4 is the same as 2, and I'm still subtracting out 3/4. I'm going to ignore that whole number for a moment. 4/4 minus 3/4 is 1/4. My whole is still the same, so I end up with 1 and 1/4. So I can always take those whole numbers and convert them into a like fraction. Continuing on with mixed numbers here, let's say we have this type of problem. 5 and 5/12 minus 2 and 1/12. Now when we get into mixed numbers, some people prefer, and I personally prefer, to write it like this, so it's more vertical than horizontal. But that is a choice. It's not necessary. Either way is fine. But I'm going to ignore my whole numbers for a moment just to see if I have enough of these 12ths to take away this many 12ths. And so I have 5 of these 12ths. I have 1 of these 12ths. Okay, well 5 is more than 1, so I can actually do that. And 5 minus 1 is 4/12. So if I take away 1/12 from 5/12, I get 4/12, and 5 minus 2 is 3. So I'm left with 3 and 4/12. But I do notice that I can simplify that. 4 goes into 12, and so I end up with 3 and 1/3. I can reduce 4/12 to 1/3, and that would be my final solution. Now I can double check this using a picture model. So I have, here's my original problem, 5 and 5/12 minus 2 and 1/12. And I've just written this down as a picture model. I didn't draw out all of the holes because I didn't think that was necessary. But here's 12ths. This was a hole, and here's 1, 2, 3/12, 4/12, 5/12, and I had 1/12 there. So I'm going to take away one of these from here. And if I end up with that, I end up over here with 1, 2, 3, 4/12 left. I don't want to forget about my holes. 5 minus 2, that's 3. So this is just another way of showing 3 and 4/12, or again, simplifying to 3 and 1/3. Any of those methods will work.